In this video, we're going to go over the AP Calculus AB, FRQ number 2 from 2002. And so in this problem, we're talking about people entering and leaving an amusement park. Important things, this equation E of t is the rate at which people enter. L of t is the rate at which people leave. And we're talking about this time frame here from 9 to 23. And there are no people in the park at time t equals 9. Part A, how many people have entered the park by 5 p.m., which is t equals 17. Now, important to notice, this is not saying how many people are in the park, just how many people have entered the park. So I don't actually care about how many people have left, and I don't actually even care if there were people in the park originally. Now, in this case, there weren't, but sometimes we have to worry about that sort of initial condition. So for part A, how many people have entered? And because we're given the rate at which people enter, we know that the definite integral of that rate is going to give us how many people enter. So in this case, here's my rate at which people enter. The definite integral of that is always going to give me the number of people, the net change in the people who have entered. And it's from 9 to 23 because we start at time t equals 9, or sorry, 9 to 17 because we start at time t equals 9. And they're asking us about 5 p.m., which is t equals 17. We'll just go ahead and put that into our calculator. If you do that, you're going to get 6,004.270. Now, important to read carefully, the question says to round to the nearest whole number. So we do need to make sure that we round that and say, okay, our actual answer here is 6,004. Part B, now we're talking about the price of admission. So it's $15 up until 5 p.m. And then after that, the price drops to $11. How many dollars are collected from admissions on a given day? So we need to figure out how many people paid $15, which is how many people entered up until 5 p.m., and then how many people entered, or how many people paid $11, which is how many people entered between 5 p.m. and when the park closes at time t equals 23. So for part A, we already have that. Now part B, I need 15 times my previous answer. And I'm going to do that unrounded, so I'm just going to keep it as 15 times the integral from 9 to 17 of e of t dt plus 11 times the integral from 17 to 23 of e of t dt. You could say, well, it would make sense if I did 15 times the 6,004 rather than 15 times the 6,004.270, but I'm just not going to round until the very end. That feels like the slightly more accurate way to do this. And if I do that, I'm going to get $104,048 rounded to the nearest dollar amount. Right, so that's part A and B. Now I'm going to go ahead and get those off the screen. So if you need a second to pause, look at those, go ahead and do that now. Now moving on to part C, they're defining h as this function here in terms of a definite integral. And it tells us what h of 17 is. It asks us to find h prime of 17 and then explain the meaning of both in the context of the amusement park. Let's start with just the h of 17. Like, what is that? Because we already have that value. So if we just look at the equation, h of 17 is going to be the integral from 9 to 17 of e of x minus L of x dx. And they told us that that equals 3,725 to the nearest whole number. Well, think about what each of these things are. E of x is the rate at which people enter. L of x is the rate at which people leave. So the difference between those two things would be the overall rate of change of the number of people in the park. So what this 3,725 should represent is the net change in the number of people of the park from time t equals 9 to time t equals 17. But we also know that there was no one in the park at time t equals 9. So this net change is actually how many people are in the park. Now, it wouldn't be wrong to say this is the change in the number of people in the park from 9 to 17. But it's a slightly better answer to say this is how many people are in the park. How many people in the park? And I could say at t equals 17. That wouldn't be wrong. But I'm going to say at 5 o'clock. Again, I think that's a slightly better answer because it's more contextualized. Now, what about the h prime of 17? Well, anytime I'm looking for the derivative at a particular value, the first thing I'm going to do is just find that derivative. So again, I look, okay, here's h. It's defined in terms of a definite integral. If I take the derivative, the fundamental theorem of calculus says, well, the derivative is just going to cancel out this definite integral. And all that's going to end up happening is I'm going to replace these x's with that t. So h prime of t equals e of t minus L of t. And thus h prime of 17 equals e of 17 minus L of 17, which we'll just plug that into our calculator, and we're going to get about negative 380. Because we do want this, actually, find the value. No, this one they don't want. It was they gave us the 3,725 rounded, but this one they didn't say should be rounded to the nearest whole number, so I'll round it to our standard 3 decimal places, 0.281. And that's a derivative, so it represents the rate of change. And what is it the rate of change of? Well, since h is how many people are in the park, this is the rate of change of people in the park, which I also already knew because I knew that e of t was the rate at which people enter, L of t was the rate at which people leave, so the difference in those is the rate of change in the number of people. So we would just say I'm going to need some more room. Let's wipe this guy up a little bit. The number of people in the park was decreasing by 380.281 people per hour at 5 o'clock. It always helps. It doesn't say I have to include those units, I don't think, right? Just explain the meaning, but units are often a helpful way to explain the meaning. So this is people per hour, and it's always important when you're explaining a derivative to indicate that it's at a particular time, because that's what makes a derivative so special, is it's at a particular time, not over some interval and then representing an average rate of time. It's at 5 o'clock. This is what our rate of change was. Again, pause, write all that down. I'm going to clear that out of the way so that I can do part D. So in part D, we want to know at what time do we think that the number of people is going to be a maximum. And so anytime I'm thinking about a maximum, I'm thinking about, all right, what's the derivative where does it change from positive to negative, and thus where is it first 0 or possibly undefined. So I'm saying, okay, what's my derivative? I need to know where that's 0. So my derivative, as we just said, is e of t minus L of t, the rate at which people enter minus the rate at which people leave. I need to know where that thing is 0. And again, it's a calculator allowed question. So I'm just going to solve that on my calculator. I'm going to either set these two equations equal to each other and solve for where they intersect on this interval between 9 and 23, or I'm going to look at this whole thing and see where it crosses the x-axis. And if I do that, I'm going to get t is approximately 15.794. And in this case, they don't actually ask me to justify that that's a maximum. So I'm not going to get any points for knowing for sure that that's a maximum. But I do want to know for sure that that's the maximum, because my maximum could be at 9 or 23. Now, this, I didn't say this carefully enough, but this is the only critical number in between there. But my maximum could still be at either of the endpoints. But if I look at the graph, when I actually graph this and find its x-intercepts, I can see that for the left, if I just try to draw a really rough version of this here, the graph does something like this. It goes way up and then it comes down. And here's my 15.794. So this is my rate. It's positive this whole time, and then it switches to negative. So certainly my maximum can't be at 9 over here, because the rate continues to be positive. More people are coming than leaving. Or the rate of change is overall positive. And then it can't be 23 either, because now more people are leaving than were arriving, and so that can't be my maximum. So this has to be my maximum. Now again, I don't have to write any of that down in this case. Sometimes you have to justify and you'll need to write that down. But in this case, you don't have to write it, but you still need to know it, because you don't want to just say, oh, this is the maximum, when in fact it was at one of the endpoints. So even if it doesn't say justify, you still need to justify for yourself. Just don't have to write it down. All right.